So in this video we're talking about partial fraction decomposition and using it as an integration technique. Partial fraction decomposition is really useful. You don't just use it as an integration technique. Later on in differential equations you use it for inverse Laplace transforms a lot. So this stuff is actually really handy, and you will definitely be using this later on. So basically you start out with an integral like this one, minus x minus 6 dx, and this integral is, you can't, from the techniques that you should know now, there's no way to evaluate this integral without decomposing it into its partial fractions. So you can't do any use substitution. Nothing will work really. Well, I'm not going to say nothing will work because I didn't go into extensive detail, but the standard method for doing these types of integrals is partial fraction decomposition. So just as an example of what we're going to get, when you decompose this, you get these two fractions, and if you do the math, this is actually a 2. Oops, a 2. Why am I having such trouble here? 2. Okay. When you do the math and you combine these two fractions, they will give you this fraction. And the logic here is that these two fractions are equivalent to the original one, and therefore their integrals must be equivalent. And these two fractions here are easy to integrate. They're just the ln of the absolute value, x minus 3, and then we have minus ln of absolute value x plus 2, and then plus c. So not bad at all once you decompose them. The question is, how do you decompose them? Now, here are the rules, so to say. So basically, if we insert something in here, what you do is you factor the denominator. Let me put this in an integral sign. And if you factor the denominator, you get this. And that should look familiar because these two factors occur in these two, and that's exactly what happens. You factor the denominator, and then you set each factor equal to its own term on the other side. But the question is, what do you put in the numerator? And the first step in this problem would be to write a over x minus 3 plus b over x plus 2. Just any arbitrary number above them. So and we set that equal to the original fraction, like that. Now, well, there are more rules to what you put up here, and we'll get to that in a second. But now, since these two are equal, now we can multiply both sides by this denominator here. So if we multiply both sides, I'm just going to explicitly show that, just so it's more clear there. So we multiply both sides by that, make a new line. This all cancels to just 3x plus 11. This x minus 3 cancels with that one, and then we just get a. This x plus 2 cancels with that one, and we just get b. Now, there are two ways to do this. The easy way out is to realize that this is an these two sides are an identity, excuse me, and therefore are equal. So any value of x we put in will make the statement is equal on both sides, and then we can use those values of x to solve for a and b. So if we make x is equal to 3, that's going to be, well, 9 plus 11 from the left hand side is 20, and that equals 5a, and then this one vanishes. See, that's the trick, is to use values of x that make a term go away. So that means that a is equal to 4, and that's indeed what we have up here, 4. And then now we use the other one, x equals -2, and when x equals -2 we get -6 plus 11, which is 5, or 11 minus 6, which is 5, and then that equals well, the a term, the first term goes away, and we have -5b, so that means that b is equal to